We all know that what makes Marvel stories so addictive, it's the fact that they never really end. The Avengers can go back in time, Loki can come back to life even after he's already dead, and 3 different Spider-Men can exist in the same story at the same time. All of that can happen because Marvel is built on one insanely complex idea, the idea of the multiverse, a concept that says the reality we're living in right now is not the only one. It branches, which means one person could have multiple versions of themselves, living completely different lives in entirely different worlds. Now let me ask you something. Do you actually believe this could exist in real life? Probably not, right? I mean, what kind of crazy person would actually believe something like this? That just sounds like a kid's fairy tale. But here's the problem. Some physicists actually don't think this is fiction at all. They believe that this idea, where reality splits into multiple outcomes, is a real consequence of how the quantum world works.
Multiverse is real.
But the natural consequences of what you need to explain this universe will, by force, be creating these other universes.
That is correct, and it seems very hard to avoid.
But believe it or not, elements of that are actually encoded in the laws of physics.
It's not mystery, it's not magic, it's just science.
And in physics, this idea is known as the many worlds interpretation. In this video, we're going to break down how the reality we've always thought was just one might actually be branching just like in Marvel. So get your brain ready, because some of the ideas we'll talk about might genuinely blow your mind. Let's talk about it. Alright, for those of you who are into Marvel, you probably remember this scene. The scene where Loki is watching himself getting killed by Thanos. But here's the thing. This version of Loki isn't in some kind of afterlife. These are actually 2 different scenes, happening in 2 different realities. In one reality, Loki is alive, but in the other, Loki is dead. It's almost like he's both alive and dead at the same time. Both of them happen, and both are experienced. So now the question is, which one is the real reality? Is it the Loki who lives, or the one who dies? Alright, let's hold that question for a second, because before we go any further, you need to understand that what's happening to Loki here is almost exactly what happens in something called Schrödinger's cat. Have you ever heard of it? It's the story of a cat that is trapped inside a box with poison. And just like Loki, this cat is both alive and dead at the same time.
They have split. They have gone their own way. It is as if they have become 2 separate worlds. There is a you that sees the cat awake, and there is a you that sees the cat asleep.
Sounds ridiculous, right? But this isn't a myth. It's not fiction. This was actually an experiment proposed by a physicist named Erwin Schrödinger, one of the most important scientists in modern physics. And this experiment is what eventually led to the idea behind the multiverse. Or in science, they call it the many worlds interpretation.
The physical world that we see around us, the room, the stars, galaxies, and so on, is just one tiny sliver of the whole of reality. And the whole of reality includes many such objects, many of the kinds of objects that we have traditionally thought of as the universe. And so it's sometimes called the many universes theory. I actually prefer I prefer to call it the multiverse theory.
But before we go any deeper into Loki, Schrödinger's cat, and the multiverse, we need to take a step back. Back to the quantum world where all of this weirdness actually begins. In our everyday lives, everything feels predictable. Like if we throw a ball, let's say a basketball, we already know where it's going. We can even calculate its trajectory using clear and precise equations, which means if we know the starting conditions, we can accurately predict what's going to happen next, right? But all of that certainty starts to fall apart once we move into the smallest level of reality. Because in the quantum world, the laws of physics we've always relied on don't really work the same way anymore. In the previous video, we briefly touched on something called superposition, a state where a particle can exist in 2 or more places at the same time. But if we really start to look deeper into the quantum world, we will realize that superposition is not just about position. It's not just about being here or there. It's about the state itself. Wait, what? What does that even mean? Well, it turns out the answer actually comes from this equation. This is an equation developed by Erwin Schrödinger. In simple terms, this equation tells us that at the quantum level, a particle doesn't have a definite state. Not its position, not its condition, not even its existence, until it's observed. And that is what we call superposition.
And superposition is what I described before, where you can be in two states that you thought are like very distinct, right? You can only be in one or the other at any one time, okay? But quantum tells you that you can be in both, and in fact, most often, you are in both of these states at the same time.
Sounds really confusing, right? Yeah, it is. And that confusion is exactly what made Einstein hate the quantum world. But ironically, Schrödinger felt the same way as Einstein. He wasn't comfortable with how absurd superposition is, even though he was the one who came up with the equation. And to show how absurd superposition really is, he proposed a thought experiment known as Schrödinger's cat. Schrödinger imagined a scenario where a cat is locked inside a box, but the cat isn't alone. Inside the box, there's also a vial of poison, a radioactive material, and a detector that is connected to a hammer. Now here's how the setup works. If the radioactive material decays, the detector is triggered, which then activates the hammer, and the hammer will break the vial of poison. If that happens, the poison is released, and the cat dies. But if the radioactive material doesn't decay, then nothing happens. The cat will stay alive. So everything depends on one thing, whether that radioactive material decays or not. And this is where the problem begins. You need to know that radioactive decay happens at the quantum level. And like we talked about earlier, in the quantum world, everything exists as probabilities. Nothing is certain until it's observed. And since the radioactive material is sealed inside the box, and we can't directly observe it, we can't say for sure whether it has decayed or not. Which means, as long as we haven't seen inside the box, we have to assume that the radioactive material has both decayed and not decayed at the same time. And this is the paradox Schrödinger was pointing at. If quantum theory forces us to accept that the radioactive material exists in two states at once, then how about the cat? Because the cat's fate depends entirely on that process, so we have to assume that the cat is also in the same kind of state, a state of superposition, which means the cat is alive and dead at the same time. And only when we open the box, only when we observe it, we can finally say whether the cat is alive or dead. But until that moment happens, both possibilities exist at the same time. Okay, let's pause here for a second. I know that sounded really confusing, and you're probably thinking this whole scenario is completely absurd, like it just makes no sense at all. But that's exactly the point Schrödinger and Einstein were trying to make. How absurd reality would become if quantum theory really worked this way. Because at the end of the day, the quantum world is the foundation of everything in this universe. And if that foundation itself is this strange, then the reality we experience every day might not be as simple as we think.
The point of this thought experiment, which Schrödinger and Einstein invented over the course of letters sent across the Atlantic Ocean, was not to say, wow, quantum mechanics is impressive. It's to say, surely you don't believe this.
And this is where the real debate begins. Because for many scientists, this conclusion just doesn't make sense. I mean, is it true that reality depends on whether we see it or not? Is it true that something can live or die just because it hasn't been observed? All of these questions eventually became one of the biggest problems in quantum physics. So how are we supposed to make sense of all this? Well, some scientists chose to accept it as it is. They argued that all possibilities do exist, but the moment we observe it, reality chooses just one outcome. This idea became known as the Copenhagen interpretation, a framework where the wave function, or the state of superposition, collapses into a single reality when we observe it. But not everyone was satisfied with that answer. Some scientists started asking a deeper question. Where do all the other possibilities go? Do they just disappear, or are they still there? And this is where a young scientist came in with an even more radical idea. Hugh Everett, in his paper, proposed something that completely different. He basically said, what if all of those possibilities actually do happen, just not in the same world, but in different ones? Which means, when we open the box and see the cat alive, it doesn't mean the dead outcome disappears. Instead, reality itself splits. In one world, the cat is alive, but in another world, the cat is dead, and we only ever experience one of them. This idea later became known as the many worlds interpretation, or the multiverse in Marvel story. Everett's argument was originally presented in a complex mathematical formulation. According to Everett, the only thing that is truly real in this universe is the wave function itself, the state of superposition. Because that's the most fundamental law that governs everything. Which means, from the very beginning, the entire universe has always existed in a state of superposition. And in the case of Schrödinger's cat, Everett pointed out something important. It's not just the radioactive decay that's part of the quantum system. The entire setup, including the cat itself, has always been part of that system. Which means, the cat is genuinely in a state of superposition. It's actually alive and dead at the same time. But wait, if that's true, then why do we only ever observe one outcome when we open the box? According to Everett, that's because of something called quantum decoherence. In simple terms, every time a quantum system interacts with its environment, like when it's observed, the superposition doesn't collapse. Instead, it splits into separate realities. And that is the scientific version of the multiverse. But can we actually interact with those other universes like in Marvel? The answer is no, we can't. Scientists argue that once reality splits, the information in each branch is no longer shared. And once that information diverges, there's no way for those realities to interact with each other anymore.
They have split. They have gone their own way. It is as if they have become two separate worlds. There is a you that sees the cat awake, and there is a you that sees the cat asleep, and these two versions of you can never talk to each other. They can never compare notes.
So at this point, what do you think? Do you believe this scientific version of the multiverse is actually real? Or is it just something that exists on paper? Well, that's for you to decide. Because in the end, it's simply a matter of faith. And that's why it's called interpretation, something that is based on mathematical calculations. But at the same time, don't forget if the idea of the multiverse in science doesn't come out of nowhere. It comes from a real phenomenon, something that has actually been tested in laboratories. A phenomenon that was later formulated by Erwin Schrödinger into an equation. Even this equation is often considered one of the most successful equations in the history of science. Because through that equation, scientists were able to understand and map out all the elements in the periodic table, which eventually led to the technologies we use today. So in a way, many scientists don't even bother arguing too much about how reality really works. Because no matter how strange the quantum world is, as long as the equations work, that's what matters. It's kind of like using an iPhone. We don't need to understand how it works internally, we just need to use it.
The problem is we understand quantum mechanics and use it in exactly the same way that I use my iPhone. I can send signals, I can use apps, I can send texts, even phone people on my phone. But if you say, what's going on inside? How do I build one of these? What are the details? I have no idea.
And now, back to the question from earlier. Which version of Loki is the real one? The one who lives or the one who dies? According to Everett, the answer is both are real. Both actually happen. But just like the cat, they exist in different worlds. And maybe the reality we're experiencing right now is just one of many possibilities, the one we just happen to live through.